And now for the oldest question of all time. Why is the sky blue? Here on Virtually Rick, we want to arm you with the answers, so the next time a kid puts you on the spot, you won't have to be embarrassed, change the subject, or buy them candy to shut them up. Ready? So, come with me. Let's get virtual. And the sky is a lot like Isaac Newton's prism experiment. Do you remember that one from school? At this point, it's a brilliant excuse for me to show you this. Pink Floyd's album cover. As you can see, the prism splits up the white light into a spectrum of colours. And probably your mind too if you're listening to the album. Now, let's start with your TV screen. And you can see here that we're seeing white on it, yes? Does it look white to you? Well, of course it does. Or does it? If you look a bit closer, you shall see that there are, in fact, pixels on the screen. And those pixels are actually red, green, and blue. And when all three colours in a pixel shine with the same strength, it tricks our eyes into thinking that we see white. Genius! Now, don't ask me to explain why orange is the new black. But white light from the sun is made up of lots of colours. How many? Have you ever seen one of these before? Of course you have. It's a rainbow, and it's made up of 7 colours: red, orange, yellow, green, blue, indigo, and violet. So, why are the colours of a rainbow always in the same order? Because these colours each travel at different wavelengths, like the different radio stations that our eyes are tuned into, as our eyes and brain know precisely which colour we're seeing. Tune to a long wavelength and you see a red colour. Tune them to a short wavelength and you'll see blue or indigo or violet. But we can only see what's visible, not invisible. Well, obvi. In fact, if our eyes were more sensitive, we'd see a lot more stuff on what's called the electromagnetic spectrum. But we can't, so stop it. So, why do we see a rainbow in the first place? Well, raindrops. Light moves pretty fast. You've heard of the speed of light, right? Well, it turns out you can slow light down if it passes through things, and it slows down as it passes through a drop of water, which bends or refracts the light, separating it out into all those colours that make up the white light in the first place. So, back to Pink Floyd again. Yeah, man, cosmic, yeah. Except, of course, way bigger and in the sky. Okay, that's enough. So why is the sky blue? We have to answer that question, for goodness sake. Well, I'm getting to it. Simplifying this massively, white sunlight is moving fast until it hits the atmosphere, and then it slows down, and most of the top colours of the rainbow, reds, oranges, and yellows, make it through. And you see them as, of course, a whitish sunlight. But the blue and violet colours are just the right wavelength to bounce off the particles of gas in the atmosphere, so they get separated from the other colours. And they get scattered all over the place, making the sky appear blue. So, now you know. Easy, huh? Actually, perhaps it's easier when kids do ask you to tell them why the sky is blue to say that you don't know. I grew up in England where the sky was always grey. And please don't ask me to explain that.